Everyone, go ahead and open your books to page 187. We're going to be in lesson 12.4 talking about slopes of parallel and perpendicular lines. Describe the relationship among the slopes of parallel lines and perpendicular lines. And then we're also going to focus on writing an equation of a line that contains a given point. So sometimes this point is going to be an x1, y1 coordinate point, or it could be our y-intercept. And our slope is going to either be parallel or perpendicular. And we're going to spend a couple days practicing these things. So, where do we see parallel lines in nature? Here are some examples. Parallel lines, they never touch. They're equidistant from each other at all points. What about perpendicular lines? Perpendicular lines intersect, and when they intersect, they form a 90-degree angle, a right angle. So question 1, if we're looking, we have a graph, and there are 4 lines, and they're labeled L1, L2, L3, and L4. And you are going to determine the slope of each line. So I want you to pause the video, and I want you to find the slope of all of these lines. So you need to put points on these lines. And remember, you're counting rise over run. You can do it. So line 1 has a slope of up 1 over 2, so it's a positive 1/2. Line 2 has the same slope, up 1 over 2. Line 3, I'm going down 2 boxes over 1, 2, 3. And line 4, down 2 over 3. Don't forget about your negative. Line 3 and line 4 are decreasing or declining, so these slopes are negative. So question 2 says, in the graph, line 1 is parallel to line 2, and line 3 is parallel to line 4. Do you see that? So what could we say about the slopes of parallel lines? What do you notice? Slopes of parallel lines are the same. Line 1 and line 2 both have a slope of 1/2. Line 3 and line 4 both have a slope of negative 2/3. They're parallel, so they have the same exact slope. That's why they never intersect. They never touch. Question 3. Determine the slope of a line that is parallel to the line whose equation is y equals negative 3x plus 4. Well, if I'm looking at this equation right here, what is the slope of that line or this equation? It's the number in front of the x. It's my m. So this slope is negative 3. So what's the slope parallel to that? it would be the exact same. So it would also be -3. Okay, so if I had a line with the slope of 5, a line parallel to that would also have a slope of 5. If I have a line with the slope of -2/7, a slope parallel to that would also be -2/7. Question 4 says write an equation of a line that is parallel, so same exact slope, to this line. Well, what's the slope of this line? Let's highlight it. The slope of this line is 3/4. So what's the slope of something parallel to that? The slope parallel would also be 3/4. Perfect. It's the same. And it has a y-intercept 0,5. Ooh, this is my b value. So let's write our new equation as y equals mx plus b. So y equals m is 3/4x plus b, and b is this 5 right here. So plus 5, and that would be my answer. Y equals 3/4x plus 5. Okay, these are parallel. Notice what's the same. My slopes here are the same. They both have a slope of 3/4. So they're both going up 3 boxes over 4 boxes, up 3 boxes over 4 boxes. What's different though is this y-intercept is a -1 and this y-intercept is a 5. Those have to be different so that they're different lines. Question 8. So I'm going to skip some questions here. Go down to question 8. A line is parallel to y equals 3x plus 2. So what's the slope of that line? The slope is 3. Good job. And it passes through this point right here. Ooh, let's label this point x1, y1. So what's the slope of the line above that I highlighted in green? 3. Good. And what's the slope parallel to that? It's exactly the same. Good. It would also be 3. How do we know? Since it's parallel, it has the same slope. Perfect. Question B says write an equation of the line. Well, if I have the slope from question A and I have a point in my box, this needs to be written in point slope form. So if you remember, it's y minus y1 equals mx minus x1. So we're going to do some substitution here. Remember, this x1 is going to be this value. My y1 is going to be this value. And then your m is going to be this 3 that we highlighted. Okay, so let's plug it in. Are you ready? Y minus y1, which is 4, that's highlighted in blue, equals m is your slope in green, 3, parentheses x minus x1, which is in yellow, and it's 1. So that would be our answer. Good job. Now we could take this and convert it to slope-intercept form by distributing and solving for y, but for the sake of time, we're just going to leave it. So again, just as a reminder, parallel lines have the same exact slope. Parallel lines never touch, they never intersect, they stay the same equidistance away from each other the whole time. Same exact slope. But they have different y-intercepts. Okay, question 9. We're going to switch gears here and we're going to talk a little bit about perpendicular. Okay, perpendicular. So what we're going to do is we are going to graph L5 and L7. Okay, so you should see that you have a graph in the My Notes section of your book. L5 has a slope of -4/3, and it contains this y-intercept, this point 0, 2. So on our y-axis, let's go up to 2 and go ahead and plot your point. Okay, now what we're going to do is we're going to use our slope, which is our rise over run, and that happens to be -4/3, 4/3. So I'm going to put my pen or my pencil on this point, this y-intercept, and I'm going to go down 1, 2, 3, 4. And I'm going to go right 1, 2, 3 boxes, and I'm going to put my point. Keep my pencil there, and I'm going to do the exact same thing again. Down 1, 2, 3, 4. Right 1, 2, 3. 1, 2, 3, 4. Right 1, 2, 3. Now I'm going to go back to my y-intercept 0, 2, and I'm going to go the opposite direction this time. So I'm going to go up 4, 1, 2, 3, 4, left 1, 2, 3. And I can't go up 4, left 3 anymore because I'm going to be off my graph. So I've put as many points on my graph as I can, and now what I'm going to do is I'm going to use a ruler or a straight edge, and I'm going to connect these points. So go ahead and do that, and I'm going to label this L5. Now let's graph line 7, L7. This time, my rise over run, or my slope, is 3/4. And my point is -2, -1. So this is x, y. So remember, we have to go in and out of our elevator before we can go up and down. So let's go left to -2, down to -1, and there's your point. And we have a positive slope this time. So I am going to go up 3 boxes, right 4 boxes, up 3 boxes, right 4, up 3, right 4, till I can't draw any more. And then I'm going to go back to that first point I drew, which is -2, -1, and I'm going to go the other direction. So down, 1, 2, 3, left, 1, 2, 3, 4. And again, I'm going to use a ruler or a straight edge to connect these points. And I'm going to label this with an L7. So these lines are perpendicular. If you can tilt your head a little bit, they intersect to form 90-degree angles. What do you notice about these two slopes? Right here, what do you notice? There should be two things we notice. Good, perfect. The numerator and the denominator are flipped, or they're switched. One has a 4 in the top, one has a 4 in the bottom, and vice versa. Okay, we call those reciprocals. Which means the fractions are flipped. The numerator and the denominator switch places. Perfect. What else do you notice? The signs are different. So we call those opposite reciprocals, which means one was a positive sign, one was a negative. Good job. Opposite reciprocals. One slope is positive, one slope is negative. Opposite reciprocals. One's positive, one's negative, and then we have to be flipped. Okay, one's positive, one's negative, and we have to flip them. So let me give you another example, and you can write this down in the My Notes section of your book. Okay, if I have a slope of the first line, let's say my slope is 5. We're going to write the slope of the second line. Okay, this is a positive 5. Your new slope has to be negative. Good. So this was a positive 5. Your new slope has to be negative. Now, that's not currently a fraction, but all whole numbers are being divided by 1. So if I make it into a fraction, now let's flip it. So now my new fraction, 1 would be on the top and 5 would be in the denominator. Okay, we're going to jump to question 13. Line 1 contains the points 0, -1, and 3, 1. So we are going to find the slope of line 1. Do you remember the slope formula? It's y2 minus y1 over x2 minus x1. So we could label these points x1, y1, x2, y2. Okay, so if I'm writing it out, it's going to be y2 minus y1. So 1 minus -1. Well, two negatives make a positive, so that turns into 1 plus 1, which is 2, divided by In the denominator, we have our x's. So it would be the second x, which is 3 minus 0. 3 minus 0 is just 3. And this does not reduce or simplify. So 2/3 is the slope of line 1, the first line. Let's find the slope of line 2, the second line. So let's go back up and I'm going to read the directions. It is perpendicular to line L2. So what do we know about perpendicular slopes? They have to be opposite signs. So if this is a positive 2/3, line 2 needs to be negative. Okay? And we need to flip the fraction. Right? 3 wants to move upstairs, 2 wants to move downstairs. So 3 is going to be in the numerator, 2 is going to be in the denominator. So they flip places. They flip spots. Okay? Now, let's write an equation of each line. So we're tying everything together that we've learned from activity 9 and activity 12. So for line 1, I know my slope, or my m, is 2/3, and this right here is my b value. This is my y-intercept. So let's write y equals, n is my slope, or my b, from question A. So 2/3 x, b I circled above, minus 1. Good job. Line 2, L2. My m is boxed in right here from question A. And what we know about line 2, it contains this point, negative 1, 2. That is a point. So I need to write this in point slope form, which is y minus y1. So y minus 2 equals m, which is your slope, so negative 3/2, parentheses, x minus x1, which is a negative 1, and 2 negatives make a positive. Good. And we can just leave our answers like that. Question 14. I want you to pause the video in just a second, and you're going to answer A, B, and C by yourself. So you're going to look at these questions, and you're going to write down whether these slopes are parallel, meaning exactly the same, perpendicular, which means they have the opposite signs, one's positive, one's negative, and they're reciprocals, meaning they're flipped. Or are they neither? So go ahead and pause. Do 14A, B, D. You can do it. So for letter A, if I make the first one a fraction by putting a 1 underneath that negative 4, first of all, are they parallel? Are they exactly the same? Negative 4 and 1/4. No, they're not exactly the same. So perpendicular, are they opposite signs? Yes, the first one's positive, or the first one's negative, the second one's positive. Perfect. Are they flipped? Yes. So this is perpendicular. Letter B, what do you think? Are they exactly the same? -3 and 3, are those identical? No, so they can't be parallel. Okay, perpendicular. Is one positive and one negative? Yes. And then are they flipped? Did we flip the fraction? So if this is a -3 divided by 1, the second slope would have to be a 1/3 in order for them to be perpendicular, and it's not. So letter B is neither. Doesn't work. They're not reciprocals of each other. Question D. Ooh, these are identical, 1/2 and 1/2. So that means they are parallel. Good job.